This is number 45A from your homework. This is a limiting reactant problem, and I've gone ahead and written the equation for the reaction that was given to you in the book and balanced it. I have already looked up the molar masses for each species in the reaction so that I don't have to waste time calculating that within this recording, and also giving you names so that you know what I'm referring to. In the text of the problem, you were told that you have 5 grams of each reactant, and they want to know which one's the limiting reactant. After you determine that, they want to know how much extra of your excess reactants do you have left over. So the first thing we need to do is go from 5 grams of each reactant to grams of one of our products. It doesn't matter which product you pick. I'm going to use boric acid because it's the first one in the reaction. If you chose to do sodium sulfate, you would still determine the same limiting reactant and would use that to do the rest of your calculations, and you would still get the same answers. So like I said, I'm going to start with borax, and we had 5 grams of borax, so we're going to stoich 5 grams of borax, and I'm going to abbreviate that BO, and grams on bottom because we need that to cancel. And remember, the only place you can go from grams is to moles. Next comes our mole ratio that comes from our balanced chemical equation that's going to get us from moles of what we have to moles of what we want. And for every 1 mole of borax, there are 4 moles of boric acid, and I'm going to abbreviate that BA for the sake of space. And then I'm going to go ahead and convert these to grams. Now, you don't have to convert it to grams unless you don't want, usually the problem asks you how many grams of product or what is your theoretical yield. So I'm going to go ahead and convert these to grams just so you can see that. So moles on bottom, and the molar mass of boric acid was 61.8338 grams. So according to, if borax was your limiting reactant, you would create 6.15 grams of boric acid. Okay, guess what? We get to do it again. This time we're going from 5 grams of sulfuric acid. I'm going to abbreviate that SA. Molar mass is 98.0791 for 1 mole of sulfuric acid. And then to get us from moles of sulfuric acid to moles of borax, we have to use our mole ratio from the balanced equation. And then again, I'm going to go ahead and convert to grams because that's what we are most used to seeing, and you'll have to do anyway on your test. So this one gives us 12.6 grams of boric acid. This is obviously not going to be our limiting reactant because we've already got less there. So we know this one is one of our excess reactants. Well, there's still the question of water. It's only 5 grams. It's not much. So 5 grams of H2O, 18.01532 grams of H2O per 1 mole. And according to our balanced equation, there are 5 moles of water per 4 moles of boric acid. And again, I'm going to grams. And you actually get 13.7 grams of boric acid. Not necessarily what you would expect. So therefore, both sulfuric acid and water are in excess. Borax is your limiting reactant, and the theoretical yield of boric acid is 6.15 grams. Okay, so we've answered the first question. Which one of our 3 reactants is the limiting? We have determined that it is the borax. The next question is, how much of the excess reactants are left over. Okay? Remember that your limiting reactant determines everything. So I'm going to erase this. And now that we know that borax is our limiting reactant, I'm going to stoich from grams of our limiting reactant to grams of each excess reactant, and then subtract to get the difference. So 201.2223 grams of borax to 1 mole. Mole ratio from the balanced chemical equation, there is 1 mole of borax to every 1 mole of sulfuric acid. And I need to convert this to grams because our initial amounts were given in grams. So let's see, 98.0791 grams of sulfuric acid. So we are going to use 2.44 grams of sulfuric acid. Now, we had 5 grams. So to get the leftover, we have to say 5 minus 2.44, which will give us 2.56 grams of sulfuric acid left over. Now, we do the same process to determine how much water is left over. Again, we start from our limiting reactant because that determines everything. So we have to start from the 5 grams of borax. And then we'll use our mole ratio. There is 1 mole of borax to 5 moles of water. And molar mass 18.01532 grams. Alright, so that says that we are going to use 2.24 grams of H2O. But to get the leftover, again, we need to subtract because we had 5 grams, so 5 minus 2.24 gives you 2.76 grams of H2O left over. Okay, so we've answered both questions in the text. Now, just for one more example, this problem doesn't ask for it, but I'm going to say, what if you only collected 4.83 grams of boric acid? What is your percent yield? And percent yield is a measure of how good your lab technique is. Could also be the efficiency of your process. And it's pretty simple. You do your actual over theoretical. Your theoretical was what you calculated earlier by your limiting reactant times 100. So our actual, I'm going to say, is 4.83. Our theoretical from when we were determining the limiting reactant was 6.15. So we are only getting a yield of 78.5%. Not too bad. I hope you enjoyed it.